Creating a mirror effect may seem like a simple task, but let's add a twist to it. Our aim is to recreate the effect demonstrated in the image. This effect is particularly useful for creating popular apps like Snapchat and Instagram, which often use filters such as the water and mirror effects. In our previous video, we looked at creating the water effect. Now we will focus on creating the mirror effect. To open Jupyter Notebook, first open Windows Explorer and create a folder for housekeeping. So I've created mine in my E: in computer vision, and I've created a folder creating mirror effects. Inside it, I've created one more folder called image. So this image is a free download from Pixabay. I will link it in the description so you can follow along. So let's get back one step and we'll open our Jupyter Notebook file in this path. Let's copy the folder path. Go to start, type Anaconda prompt. We'll be working the base environment. So I have to go to this path. So first I will type E: press enter, then CD space, and I'll paste that file path, press enter, and here I will open my Jupyter Notebook. So now we are into our Jupyter interface. Let's open Jupyter Notebook, click new, select Python 3. So we have our Jupyter Notebook file open. So the first step is to name the file. So click on Untitled, name the file, press rename. Now we'll import our libraries, import CV2, press Shift Enter. In case you get an error that OpenCV library is not installed, you can install it over here as well. So press Escape A to insert a cell above this cell and then install libraries. So you can give command !pip install OpenCV Python. So these installation names are not very intuitive, so you can search it in Google. There is no harm in searching in Google. You can always do that. Next step is to load our extension. So we have, so write it with the percentage sign, load extension. I'm pressing tab for auto completion, nb_black, press shift enter. In case nb_black is not installed, copy this and after space, paste it, then replace underscore with dash. And you can run this command again by pressing shift enter. So now let us read the image. Image is equal to cv2.imRead, and then in the parenthesis, in quotes, we have a folder image, and inside it we have a file woman.jpg. To view this file, we have to display it. So we'll use matplotlib for this. So plt. So I think matplotlib is not imported, so we'll import it first. Import matplotlib.pyplot as plt, and in your PC if matplotlib is not installed, you can install it by pressing space and matplotlib. Then you can press shift enter, then you can run this and then this one. So I have to run this one, import libraries. I'll press shift enter, and here if I press tab, I'll get my help. We have imshow, then our image name, and then we have to convert it from BGR to RGB. So in square bracket, first one is rows, which will remain same, then comma, height, which will also remain same, comma, and then we will reverse the channel. So the command is :-1. All right, plt.show, and press shift enter. So now you can see your image. The next step is the most fascinating. We'll transform the image color space from BGR to HSV and showcase the results. Let us see that how we can do it. So first we'll assign a variable image_HSV is equal to cv2.cvtcolor, and then we'll call our image, and the next step is to convert the color space. So it will be cv2.color color. I'll press tab and then BGR to HSV, this one. Press enter, and then we'll display the image. So plt.imshow and then image HSV and plt.show. Let us press shift enter. So we got an error because the spelling is incorrect. So it is plt. Let me press shift enter again. So now we have our image in HSV form. So the next step is to extract the value from the HSV color space. So keep in mind that the value channel is the last channel of the HSV image. We can use cv2.split function to hf this. So let us do that. So cv2.split image HSV. So it will return us 3 values. So let us assign 3 variables. That will be h, s, and v equal to, press shift enter. To achieve a negative effect on the image, you can use a method similar to the negatives of the photograph. So simply subtract the value channel from 255 and display a new channel value. This will create the desired effect on the image. So let me show you how to do that. What we will do is we will subtract value from 255 like this, and then we will assign a variable to it. press shift enter. To create a new image, merge the value channel with itself using cv2.merge, and we'll make sure that we'll take this negative value and we'll put this value in our 3 channels to achieve the desired final effect. So let us do that. So cv2.merge, and then in parenthesis, and again one more parenthesis, and we'll put value in all the 3 channels. All right, and then we'll assign a variable hsv underscore merge. Press shift enter. Let us give a comment as well, and then we'll display an image. So plt.imshow hsv merge and plt.show. Press shift enter. So now you can see this image is like our negative photograph. So now it's time to flip our image horizontally like this. So first I'll give a comment, invert the image, then it's HSV, merge, and now we have to invert the width. So the first is our height, then comma, then width, and then our channels. It is like that. So we are inverting the width. So 2 times colon and -1. And then you have to assign a variable to it. So image underscore inverted equal to, and then we have to display our image. So plt.imshow our inverted image, which we have to convert it to RGB. So again, row, comma, height, comma, channel, and we are inverting the channel. So the last will be double colon -1. All right. So press shift enter. Now we have to create an array with double the size. So width will become twice and height and channels will remain the same. So we'll create an area like this over here to paste our original image like this, as we can see in our photograph like this. So I'll comment it first, then I'll write np.zeros. I think numpy is not imported. Let me see. No, it's not there. So import numpy as np, and then if you don't have it installed, you can type numpy over here with a space between matplotlib and numpy and press shift enter, and then you can run this. So I'll run this, and then you will get help as well. So np.zeros, now I'm getting help. So the first argument is shape. Let us see the shape. So I'll press escape A to insert one cell above, and then I'll type image dot shape and press shift enter. So we have 83 by 1280 by 3. All right, let me just write 853 comma 1280 comma 3. So I want to make it interactive. So what if I put a square bracket and press 0? So I will get 853. This is our height. All right, why? Because this has 3 numbers. So first is 0 index, then first index and second index. So if I put square bracket 1, we'll get 1280. I hope you are getting my point. So I'll just copy this and replace it with 1280. Okay. Similarly, this is 0 and this is 2. All right. And then we have to give the data type to uint. So dtype is equal to np.uint8 and assign a variable to it. So new image will be our new variable. But we have not done still the main part. We have to double the width. So this is our width. So we'll just type into 2. Press shift enter, and now let us see the shape. So new image dot shape. Press shift enter. So you can see we have doubled our width. Let me show you. So the earlier it was 1280, now it is double 2560. Let us display it as well. So display the image plt.imshow, then our new image, and then we have to reverse the channels. So the height will be same, width will be same, and then we are reversing the channel. So double colon -1. All right, and then we have to write plt.show and press shift enter. So now you can see, so the width was 1280 and now we have 2560. Now we'll copy our original image in this portion. So let us display the image plt.imshow, and then this is our new image, and we have to convert this from BGR to RGB. So the same code, height will remain same, comma, width will remain same, comma, and we will reverse the channel. So double colon -1 and then plt.show. Press shift enter. So now you can see, so our original image is in the right half of the new image. Now here I want to show you one more thing. This 1280 is hard coded. So if you change the image from this image to something else, this code will break because maybe that image will not have a dimension of 1280. So let us make it dynamic. So as you can see, 1280 is over here. So if I give square brackets 1, I get 1280. So I can replace this code over here in place of 1280. And if I press shift enter, I will get the same output, but now this has become dynamic. So if we change the image over here, absolutely no problem. This code will work fine. Now we have to fill the left side of the image with the inverted image. So the code will be same. Few minor changes will be required. So I'll copy it. Right will become left, and new image is okay. Height will be same, but we need the first half. So colon will be first, and image will be image inverted, and everything is okay. Let me press shift enter, and we can see the desired output is achieved. We can save this file. So we can write cv2.imwrite and the desired file name which we want to save. So I'll give mirror effect.png and then our image. So it is new image. It should return true. Press shift enter. So now it has returned me true. Let us check in Jupyter notebook. I'll open this file. The file size is very big, but you can see the image. Through this activity, you have gained the knowledge of converting an image, color space, and utilizing a particular channel of the new image to establish a mirror effect. So I hope you have liked this video, and please give a like and subscribe to my channel, and I will see you in my next video.